Thank you for joining me again. Today we're talking about functions. And under this, we just solve 3 examples that will capture an aspect of function that is very important to students learning. So go quickly, we go to question 1. If f of 3x minus 2 is equals to 4x squared minus 6x plus 2, find f of 4. This is not direct substitution. Okay, there are situations where, let's quickly, I should have actually made an example on that. If you have, for example, you have f of x to be equals to x plus 3. You can be told find f of 5. This means if the function of x can be defined by x plus 2 or is equals to this, then the function of 5, that is f of 5, should be equal to direct substitution of 5 into f of x is what you will have. So you have your f of 5 to be equal to 5 plus 3, and that will be equal to 8. This is the situation for direct substitution. Now for question 1 or example 1 or exercise 1, okay, since we're solving together, I say example 1. This is just something that should have been done. You have the f of 3x minus 2 is equal to 4x squared minus 6x plus 2. To find f of 4, you first equate this. You first write this. The f of 3x minus 2 should be equal to 4. So you have 3x minus 2 to be equal to 4. Then 3x will be equal to 6. Dividing both sides by 3, x will be equal to 2. So what do we have there? It implies now that our f of 4 can be equal to whatever you have here, your 4, substitute this one, substitute it into this. You get that? So we are going to be having 4, open bracket of 2, squared, minus 6, open bracket of 2, then plus 2. So that becomes what? 16 minus 12 plus 2. And that becomes 18 minus 12. And that gives us what? That gives us 6. So our f of 4 is 6. Are we good to go? It is similar to what we have in question 2. Very, very, very similar. So we have f of x minus 4 to be equal to this, then f of minus 1. So you can say your x minus 4 is equal to minus 1, then your x is equal to 5. So automatically f of minus 1 can be equal to what? Whatever your f of x minus 4 is, substitute 5 directly into it, so you have 5 all squared plus 2 open bracket 5, then plus 3. That becomes 25 plus 10 plus 3. That gives us what? 35 plus 3, that is equal to 38. So f of minus 1 is equal to 38. But the question 3 will go this way. Question 3 say f of x equals to 1 upon x minus 1 plus x minus 1 upon x squared minus 1. Find f of 1 minus x. This is direct substitution, just like an example I started with. So this direct substitution. So whenever we see x, we have 1 minus x substituted directly into that. So you have my f of x, my f of 1 minus x and be equal to 1 upon, instead of x minus 1, I have 1 minus x, 1 minus x, takes the position of x, then minus 1, then you have plus x minus 1, that is 1 minus x minus 1, 1 minus x minus 1 upon x squared minus 1. So x squared will be 1 minus x all squared minus 1. Do you see that? So this will become what? 1 upon this 1 minus minus 1. This will become x plus 2. So nothing is cutting out there. So you have minus x. This is, oh, sorry, it's an error there. So this is plus 1. This is minus, this is plus 1. This is minus 1, isn't it? So it crosses out. So you have this and this gone. This and this gone, isn't it? So you are going to be having 1 over x, 1 over minus x. Then we have minus x upon, expand 1 minus x, what do you have? Squared. So you have 1 minus x, you have 1 minus x plus x squared. This and this, is it going? No. Minus x is minus 2x. So what do you have? You are going to be having 1 minus x plus x squared. So you have this, you have x squared minus 2x plus 1, isn't it? That's all you have. So there's already a minus 1 here too, then minus 1. So this and this will go. Do you get that? So I can now say I have this. Let me manage this side. So I have minus 1 over x minus x upon x open bracket x minus 2. Yeah, you can factor out x at the denominator there such that this and this will go. So back I'll be having minus 1 upon x, then minus 1 over what? X minus 2. So this is what I have as my f of 1 minus x. Thank you for staying with me.